This video continues on with Module 2 of Chapter 1, and in this video we'll define terms that are important in the understanding of the action potential. So the first term we're going to talk about is polarization, and we've already had a little bit of a discussion about what this part of this word means, polarization. So remember, if we're here at 0, polarization means we're making this charge inside relative to outside more negative, and so the cell becomes polarized, and at some point we get down to resting membrane potential. And so if this little semi-flat area here, let's say it's resting membrane potential, and we hyperpolarize the cell, we make it more polarized. We make it a bigger negative charge. So it's increasing the polarization, or the difference between the electrical charge of two places. In other words, the inside of the cell becomes more negative. You see we're becoming, this is negative down here, right? And this would be positive. We're measuring this in millivolts, and this would be time. So this hyperpolarization, if this is our resting membrane potential, hyperpolarization is making it more negative. And that's what this is just showing you here. So here we are at resting membrane potential. And in this cell, if we look at this graph, here's millivolts, and here's our time. And if we look here at resting membrane potential, it's not negative 70 for this cell, it's negative 90, just helping you be able to read a graph in case you need to for an assignment or for an exam. So here, our resting membrane potential is minus 90, and hyperpolarization is when the cell gets back to this resting membrane potential and it goes below 0. It's increasing the polarization between the electrical charge of two places. It's becoming more polarized than it would be at rest. That's hyperpolarization. Depolarization, on the other hand, if we think about what this term polarization means, is going farther away from 0 in a negative manner. Depolarizing is going to be taking away that charge difference. So decreasing the polarization towards 0. So again here, if we're down at resting membrane potential, whatever that may be, and we go up closer to 0, that is depolarizing. Here we're repolarizing. And again, anytime we go up towards 0, that's depolarization. And that's what just is showing you here, is that the most important part of that action potential is this depolarization. This depolarization is that action potential. It's that electrochemical signal moving down the axon through this depolarization. Here you'll see it has to do with opening of voltage-gated channels, and we'll talk about that in a subsequent video. But I just want you to understand, here we're at resting membrane potential. The cell gets depolarized to what's called threshold. We'll talk about that in a later video. And then as we go towards 0, we're depolarizing. We're taking away that charge difference, decreasing the polarization towards 0. And another term is the threshold of excitement. This is the level above which any stimulation produces a massive depolarization. So this here is a massive depolarization. Again, here we're at minus 90 for resting membrane potential. Something stimulates the cell and depolarizes it, and then we have this threshold. And here, if we were to go across from this point, which is a threshold of excitement, we go across this threshold for this cell is minus 65. Anything above that, any type of stimulation, we'll talk about local potential change, graded potential changes, another action potential traveling down, all of those things, or an electrode stimulating that cell, it stimulates the cell and depolarizes the threshold. You have this massive depolarization. And that is, again, because of the opening of the voltage-gated sodium channels.